Good day, everyone. My name is Kinza Iman, and today I am pleased to present on the topic Counting Combinatorics and their Real World Impact. This topic is drawn from my recent research in discrete mathematics and focuses on how foundational principles in mathematics apply to real world challenges in computer science, security, and so much more. Combinatorics is a branch of discrete mathematics concerned with the study of finite or countable discrete structures. At its core, it involves counting, arranging, and selecting objects, often under specific constraints. This field is particularly crucial in areas such as computer science, where it helps solve problems related to data organization, algorithm efficiency, and system design. Combinatorics allows us to model and analyze complex real-world problems by breaking them into countable and manageable elements, whether scheduling tasks, optimizing routes, or modeling genetic inheritance. Combinatorial reasoning supports logical structure and problem solving. The fundamental principles of combinatorics include the rule of sum and the rule of product for basic counting, permutations and combinations for structured selections, and more advanced tools like pigeonhole principle and inclusion-exclusion principle. Each has its own role in analyzing arrangements or counting objects with or without overlaps. Permutations are used when the order of selection is important. The general formula for permutations can be modeled by this formula, where n is the total number of items and r is the number of items being selected. For example, if we have 5 students and want to see 3 of them in a row, we can calculate this by this formula. This tells us there are 60 different ways to arrange 3 students out of 5 in a specific order. Permutations are widely used in tasks like password generation, race tournament placements, and queue management systems. Combinations, on the other hand, are used when the order of selection does not matter. The formula can be illustrated by this. Here, n is the total number of objects and r is the number being chosen. For instance, how many different teams of 3 can be made with 10 students? This means there are 120 different combinations of selecting 3 members from 10 regardless of order. Combinations are crucial in lottery systems, statistical sampling, and team selection algorithms. Let's apply these principles to cybersecurity. An 8-character password using 62 possible characters, 26 lowercase, 26 uppercase, and 10 digits has 62 to the power of 8 combinations. That's over 128 trillion possible permutations, making brute force attacks computationally intensive. This shows how combinatorics directly contributes to designing secure authentication systems. The more complex a password, the more permutations, and thus the more secure the system. In sports competitions, we often need to schedule matches efficiently. In a round-robin format, each team plays every other team once. The total number of games can be calculated by this formula. For 10 teams, that's 45 games. The simple combination formula ensures fair scheduling without redundancies and is widely used in sports tournaments, classroom project assignments, and even robotic simulations. The principles of combinatorics go far beyond puzzles. They are critical in artificial intelligence for evaluating decision trees, in logistics for optimizing routes, in finance for risk assessment, and in cryptography for key generation. These tools train our minds to think analytically and model possibilities efficiently. In summary, combinatorics brings structure and clarity to our decision making in a data driven world. It merges logic and creativity, helping us design systems, solve problems, and understand the world in precise quantitative ways. These references include textbooks and academic articles that provide both foundational knowledge and real world applications of combinatorics. Thank you for your time and attention.